And then cooling and air circulation. I would imagine air circulation is a bit more important at this time of year. But
yeah, this is huge. And Will and I were talking about, today we were saying here it's like 55 degrees, it's raining, and and you walk into any operation, and I usually see the curtains are completely pulled. They're heating.
Well, maybe not. I mean, it's in that weird temperature. I remember early on in my career, I was in Maryland at the time, and it was like 40 degrees outside. And of course, what do you think the temperature was inside the greenhouse? It was about 50 degrees.
Right.
And I said, why don't you have the heat on? He said, well, it's not too hot and it's not too cold. And so we're just going to save money and just not heat the greenhouse. And of course, you walk around and you kind of go like, they're just looking for trouble.
Right.
They don't have, they're going to have disease issues because botrytis loves to have free water, which is easy to have when you have these kind of temperatures. So one of the problems that you run into is you're not moving air. And moving air in a greenhouse is the most important thing that you possibly can do to be successful in finishing a plant, especially once you've got roots. Now the plant can take up water all by itself. You no longer have to put on mist. You have to make sure that you can move that water through the plants. Because think of it as plants are just a giant straw, okay? The leaves suck the water out, and the roots suck the water in. And so you have this continuous stream of water. Every year, it's called the week 10 problem. The week 10 problem is when growers walk into their greenhouse and go, oh, my tips are all stopped growing. I've got this runty little plant, they're not growing, what's happened? And the reason is that they've allowed it to be poor air movement, very high relative humidity in the greenhouse. I remember walking into one greenhouse that there was actually a fog bank in the far part of the greenhouse. And it's like, you guys, that's a problem.
Right.
No, it's not. We don't have to heat. I said, yeah, but look at these plants. They had total tip. It was the most amazing tip abortion problem I've ever seen in my entire life on literally everything, which is a pretty hard thing to do. They did it because they didn't move it. So let's talk about this ventilation, because you have to ventilate.
Yes, you got to
all the time.
Yeah, I mean, we like to see, as builders of greenhouses and stuff, people ask us how often should we vent in the wintertime. We usually say 1 air exchange per hour.
Yeah.
And so, but what do you do when you have a rain event, a snow event? You still have to ventilate somehow.
Right.
And that's what you're saying with the tip burn. We were talking about earlier, you said tip burns because people aren't ventilating. And so you've got kind of two problems here. If you're a really high-end facility, you're probably going to have a shade curtain system. And but at minimum, you're going to have some sort of roof ridge ventilation. You're going to have power ventilation and stuff like that. Probably your power ventilation is going to be shut down for the winter because you really don't need to pull in that much air. But you may have shutters or something like that to pull in a little bit of air. But you may only have to open those vents at least an inch or two at minimum, just to get some air out, even if it's raining outside, possibly if it's snowing, if it gets too bad, because we got to adjust that humidity down too. But a lot of people will keep their curtains completely closed, and obviously your air, very little air is going to make it through that shade cloth and shade curtain. So you were saying you think a good amount is 10% open.
Yeah, just enough so you can get convection flow. Because remember, heat rises. We talked about this earlier. Is that heat rises, and so what you want to make sure of is that you get your shades. That you either have a basically you've got ridge vents, or if you have at the ends of the greenhouses, you got some kind of a little low. You don't have to have high speed fans, just a low speed fan that can basically suck the air out of that attic area.
Yeah.
Because remember, as the heat increases, it absorbs moisture. And so it's sucking moisture out of the air, and then basically it will continue to rise and pull it out. And so that you have this slow, continuous evaporation off the plants. Because if you have continuous evaporation off the plants, what that translates into is that you then are moving calcium, you're moving boron, you're moving copper. These are the things that trigger tip abortion, right? Tip atrophy is what we call it, because basically the growing point stops growing because it doesn't have the critical nutrients of copper, boron, and calcium. So we need to keep moving that air through that greenhouse. And you even see this in the poinsettia season. At the end of the poinsettia season, where growers have bract edge burn. Well, bract edge burn is nothing more than high relative humidity in the greenhouse, and they don't ventilate. And then there's no calcium movement. If no calcium movement into the bracts, they burn. It's very simple. The edges get damaged. So that's kind of one thing. But what about horizontal airflow? What do you?
Yeah, so that's a big important thing, and I see a lot of this, and I've got right here. I've got this nice HAF fan that we have here that we use through all our companies and stuff like that. And a lot of times people will look at this and they're like, this is a really small HAF fan, but it has nothing to do with the size of the fan blade or anything like that. It's how much CFMs the plant can actually, this can move. And this particular model moves about 1470. That's 1,470 CFMs. And that's a lot of air. A lot of people don't realize that's a lot of air. And there's specific calculations to how many you should have. But it's surprising how many times you go into a propagation house and there's no HAFs running, or there's not enough HAFs. And, and different types of things you might see. Example, like I see some propagation facilities where they want to see the leaves move all the time. Well, then you got transport.
Oh no, that's scary.
Yeah.
Usually, what we usually want people to do is you make this really high tech airflow measurement device. Okay, what it is you basically take a small stick or a small wire and you put you make it into so it looks like the hangman, and then you drop just a small ribbon, a very lightweight ribbon or a light piece of thread or a couple pieces of thread, and all you want is you just want that thing not standing there hanging that core straight down. You just want just slight amount of movement. You don't want, this is not an air tunnel.
Right.
We're not testing the aerodynamics of the plants.
Right. That's actually a good point. Like a lot of big kinds of questions that I get is how many HAF fans should I have in my facility? And there's a pretty simple calculation, but you really got to know what the CFM is. So like I said, that was 1470. So I usually take a calculation of length times width of the greenhouse, and then I multiply that times 2, because that helps you with how many air exchanges that you want to have. So in most part, like if I have a 30 by 96, say greenhouse or something like that, I'm just putting out a general size, and you're gonna have this 1470, you're gonna need about 4 fans. Now, if you do the calculation and it comes up like 3.5, you can't have half a fan. Like you can't have half a fan. But if you want to have more of an even number so that you have all your fans going one direction and the other side of the greenhouse going the other direction, so that you can keep that convection of that temperature or that airflow going around in a circle. And it also helps with your heating. So we're kind of going backwards here with the heating stuff like that. Yeah. But that's kind of a simple calculation to find out how many you should have in your greenhouse per bay. And it's important that you get that airflow moving and stuff like that, because I remember when I was a grower, we used to always have edema problems. Yeah. And that was simply too much, not enough air movement,
Right. Well, basically you have dead air. Yeah. And if you can walk into a greenhouse and you can feel or taste the air, that's dead air. I go out into a foggy day and you can actually taste the water. Then you know that you've got a problem. And so what you want is you want it to feel fresh. And this is one of those funky, you need to feel your greenhouse. Yeah. And you need to feel that it's fresh, or it's, and edema is a classic example where it's got dead air, especially at night. And this is where people will sometimes say, well, I turn my HAF fans off at night. Really? Well, so if during the winter, you've got, 16 hours of dark and you've got 8 hours of light. So basically during the day, you might not need it because you've got heat from the sun and it's kind of moving the air around, but it's more critical to have it at night so that you're really moving that, you've got that nice light flow all night long. Right.
And before you brought up a good point, physics. Physics is huge with heating because like we said, heat rises. But if you've got a shade curtain system in your greenhouse, you could possibly have, and if we're real cold, we get down in the sub 40 degrees, you're closing that to retain heat underneath. But the problem is it's still cold above because it's not going to filter down. So you just can't come in at 7, 8 o'clock in the morning and open up your shade curtains when the sun's out. You got to open those gradually as you increase your heat too, right? Because you'll get a cold crash, and that's the last thing you want on a propagation crop is cold crash.
Well, yeah. Well, basically, what that is that's that whole early morning diff, where basically you get the cold and then everything stays really compact right underneath where it opens and it dumps. But so you need to just basically do it. Now the thing you have to keep in mind is that you really need to be thinking very logically about when should you be doing HAF. So right after you stick, when you're basically trying to rehydrate the cuttings, one of the worst things you can do is put an airflow on it. Right. Because at that point, you're moving too much air through and you're basically drying the cuttings out because you're not allowing that high humidity to accumulate down in and around the canopy. Right. Which is really important. So once you start breaking roots, and usually that's about 5 days, 6 days if you've got everything set up right. At that point, now you're starting to get roots, and now you want those roots to be aggressively growing, and they'll aggressively grow if they need to move to dry out. So think of it as root growth is kind of like having teenagers around. If you basically have a coffee table with sodas and beverages at galore and potato chips, how often do they move? Not much at all. So you really want to make sure that you're forcing it to grow. You're forcing the plants. So you basically move all those treats out into the kitchen, so they have to get up and go. And that's really what you're trying to do with these roots. You're trying to get the leaves to start losing water, so that the roots then start going and searching out the water, which they're very efficient at doing if you make them do that. So, be a hard taskmaster, be the adults in the room, and make sure that once you start getting roots, that you start moving air to get those roots going.
And that's important, and everything we've talked about so far, we really got to tie it in that, the mom and pops probably don't have major controllers like the big giant.
Well, they can still turn stuff on and off.
They can turn stuff on and off. But technology is starting to get a little bit cheaper in a horticultural realm, and there's simple controllers out there, controllers that can control your curtains, can control your heat, control your mist systems, that can control your lights, which we'll talk about next, and it can control your water and all that kind of. And it's all connected to some brainchild, of a controller, and they don't need to be expensive controllers. They can just be simple sensor controllers that it's hooked up to the heating into the beds, which is connected to your shade curtains, which is connected to your vents, and you can program that pretty simply in there to know it, so that you're not have to be in there exactly at 7 o'clock or 5 p.m. when the sun goes down. And you have to shut those vents and stuff like that. A lot of things are able to be retrofit, and we're seeing a lot of that. We're seeing a lot of people that are wanting to retrofit their facilities with inexpensive controller systems. There's multiple brands out there that are capable of doing it, and they're starting to get in more on the game to do that. And, as they want to be able to have a little bit of freedoms in their greenhouse where they're not having to worry about it 24/7. And then, and even more so, we're seeing cell phone controls. Right. So, if you want to make things on the fly where some of the sensors might be reading off or something like that, you can make changes from your cell phone. And it might be just a small fee from whoever the manufacturer is, just to take and log into your system and, check it from the comfort of your, as you're watching the Buckeyes or something like that, or so.
Well, I would. I went to Minnesota, a real university, and then because all the M institutions are the real ones. Those other ones that begin with vowels, we're not so sure. Anyways, we got off track. But the point of the controllers is, you don't have to, if you've got a quarter acre, you've got an acre of greenhouse, you've got a bunch of Quonsets, do you need to put controllers everywhere? No. Think smart. Where you're spending your most money is in propagation. Where you get the most bang for your benefit is in propagation. And the reason why that propagation greenhouse is your most expensive is that that's where you make and break your money. Right. Because the uniformity that you get out of that, the time you spend in there is really important. Think of that you're renting a parking space. That's how you have to think about propagation. And of course, it's just like going to an airport where you park your car for $60 a day. How many days do you want to spend in there? Not very many. You don't want to just go and park it like it's a free lot. So you really have to think about your plants and say, okay, well, we can spend more money there because it will reduce the amount of time. A grower that I talked about that went and got their HAF fans, put a decent controller where they could turn the water off when it should be off, could turn it on when it needs to be on, basically put the heat so that it was actually uniformly heating the plants, basically cut their crop times in half, which meant that they either could start later or they could do twice as much in less space. So that they basically didn't have to have, 6,000 square feet of light because they could turn the crop faster, they could do it in half the amount of space.
Right.
So, think about this as getting the technology, which is now coming down in cost nicely, to basically solve the problem that you have, not solve the universal problem. If you've got a bunch of Quonset greenhouses, as you get into the spring, the doors are open most of the time, aren't they?
Right.
And you know that it's got to get warm sometimes, so you turn the heat on. So, the level of technology you need in a finishing greenhouse is vastly different than that technology you need in a propagation facility. So let's keep thinking about, what kind of propagation do we need, conditions of, make sure we got our water set up correctly, we've got the control over that, because water is the most important. That we got the heat where it needs to be, so that we're going to heat those cuttings and get them growing nicely. And then let's make sure that we've got the cooling in there, we've got the controls in there, that we've got the horizontal airflow. Have you ever heard of the vertical airflow?
Yeah, you're starting to see that a little bit more often.
Yeah.
Yeah.
But now the vertical airflow is really for someone that's got a very tall greenhouse.
Correct.
Yeah, but how high a gutters do you have to have before you start getting into that?
16 foot plus.
Yeah, so I mean, most growers, they're not going to be at 16 foot. So it's really about horizontal airflow,
Right.
and that's good enough. Once you have these layers of technology invested, and that's how we have to kind of think about how are we going to invest that technology, get the water right, get the heat right, get the cooling, ventilating right. Then let's talk about this last piece, which everyone seems to want to talk because it's the sexy thing on the table.
Yeah.
Which is
lighting.